We're now going to do section 5.5, which has multiple angle and product of sum formulas. So it has quite a few formulas in here. You're going to have all of these on your test, so I wouldn't worry about memorizing any of them. So we're going to start with double angle formula and do a couple examples of those. And that's when we have 2 in front of the x in one of our trig functions. So like this one where we have 2 cosine x, which is normal, plus sine of 2x. So we have to get rid of that 2x. So the up above we have sine of 2u equals 2 sine u cosine u. So that's what we're going to be replacing the sine of 2x with. 2 cosine x sine x equals 0. Both of these terms have 2 cosine in them. Remember, we're always going to be looking for factoring opportunities. And then we can set both of them equal to 0. Cosine of x is equal to 0 at pi over 2 and 3 pi over 2. And sine of x is equal to negative 1 at 3 pi over 2. And it does not say that we're in the interval from 0 to 2 pi, so we have to add the 2 and pi on. We don't need to repeat the 3 pi over 2, so we'll just say pi over 2, 3 pi over 2, plus 2n pi. That was a double angle equation. Use the following to find sine of 2x, cosine of 2x, and tangent of 2x. So if I have cosine is 5 over 13, then that's my x over r. I want to find, if I look at all of my double angle formulas, they all involve sine and cosines. Tangent involves tangent, but if we find sine and cosine first, we can just divide those two. So I need to find then the sine of x as well, which would be y over r. If I'm in the fourth quadrant, as I am, sine would be negative, and this is a Pythagorean triple, so this should be negative 12/13. So let's just start with sine of 2x, 2 sine x cosine x, which is 2 times negative 12/13 times 5/13, which is negative 120 over 169. Cosine of 2x, there are 3 options. I'm going to go with the 2 cosine squared x minus 1. Cosine squared would be 25 over 169. And evaluate this, I get negative 119 over 169. And tangent, I could go through and find the tangent using the double angle formula, but I can also just divide these two. I know that tangent is sine over cosine, so I can divide negative 120 over 169 divided by negative 119 over 169. And I will get positive 120 over 119. Okay, here's the next set of formulas. These are power reducing formulas to get us out of a squared function. So any 3, we need to get rid of a squared function. This is what we do. We're going to rewrite sine to the 4th as a sum of the first powers. So we want to get rid of all of our squareds. If we have double angles, that's fine, but we just want to get rid of our power. We want to have a singular power. So sine to the 4th is the same thing as sine squared squared. It's our first step to recognize that. And then I can use, this is sine squared, pop that in there. Squared. I'm going to pull out the 1/4, which can come out by squaring. If I do that, I have 1 minus cosine 2x plus cosine squared 2x And then I'm going to use the cosine power reducing formula right there. Now it doubles. That's what the 2u means, is whatever our u was originally, we double it, which is why it turns into a 4x. And then I'm going to try to get rid of all my fractions here. Okay. Oops, this should be a 4. Combine any like terms that I have. Turns into the 1/4 plus the 1/8 turns into 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. I would leave it right like that. Now that I got rid of all my powers and combined all my like terms. Next are called half angle formulas. Remember, if you're getting overwhelmed by all the different kinds of formulas already that are coming up, that you get to use this on your test, so just know where these formulas are and how to pop stuff into them, because that's really all you're doing is popping angles and functions in and simplifying. Okay, so here's some half angle formulas. And what the point of this is if we're trying to find, like for this example, we're trying to find sine of 105, which is not a nice angle on the unit circle. But we know that 105 is half of a nice one. It's half of 210, which is on the unit circle. So if we're trying to find sine of 105, that's like finding sine of u over 2, where your u is 210. Okay, so following, I got to think about if this should be positive or negative. That's what the pluses or minus mean in front of each formula. This is in quadrant 2, which means sine is positive, so I don't have to worry about that plus or minus. 1 minus cosine of u, and like I said, our u is the big angle 210. Cosine of 210 is negative square root of 3 over 2, so that turns into plus the square root of 3 over 2. And to get rid of my complex fraction, which I have under a radical right now, I'm going to multiply everything by 2, because that will get rid of my complex fraction. So this is 2 plus the square root of 3 over 4, which is 2 plus the square root of 3 over 2. Okay, solving a trig equation, find all solutions in the interval. So the first thing I'm going to have to figure out is how to get rid of that half angle right here. Okay, so 2 times plus or minus 1 plus cosine x over 2 squared. Because we have a square root squared, those kind of just cancel out. I get 1 plus cosine x over 2. 2's cancel now. And this is much easier to deal with. Although, now I have two different trig functions. So I need to turn sine squared into 1 minus cosine squared. So now I'm left with 2 minus 1 minus cosine squared equals 1 plus cosine x. I need to be in the same variable if I'm going to factor it or solve for it. So now if I rearrange, I'm left with positive cosine squared x minus cosine x equals 0. Vector out of cosine. Set them both equal to 0. And our x's are pi over 2, 3 pi over 2, and 0. The next set is called product to sum. So if I have a product and it says to go to a sum, these are going to be really straightforward. It's going to say rewrite the product as a sum or difference. So you're going to know to use product to sum formulas. Like this, rewrite the product as a sum or difference. So we have a product, cosine of 5x times sine of 4x, and we're going to just follow the specific pattern. So cosine, sine. So if you're looking at the 4 formulas, it is the last one. 1/2 sine of 5x plus 4x minus sine of 5x minus 4x. 1/2 sine of 9x minus sine of x. You can either distribute the 1/2 or leave it just like that. Okay, so now going the other way, sum to product. If it says write the sum as a product or find the exact value like this does down here, find the exact value of these two added together, you might want to use the sum to product because then it's going to be a lot easier than finding both of them individually. You could find both of them individually using either sum or difference formulas, and then you have to combine them. But if you use the sum to product formula, it actually reduces your work. You don't have to, but it definitely reduces it. So we're looking at the third equation, cosine plus cosine. Following it, I have 2 cosine 195 plus 105 over 2 times cosine 195 minus 105 over 2. So 2 cosine 150 cosine 45. So we're almost done already. I just have to look up cosine of 150, which is negative square root of 3 over 2, and cosine of 45, which is the square root of 2 over 2, and multiply. Get negative square root of 6 over 2. So that was actually a lot faster than if I had gone through and done the sum or found these individually. Cosine of 195 and cosine of 105 are both not on the unit circle, so I'd have to use sum formulas or half angle or anything else, and then I would have to add them together. This actually makes it a lot faster. Okay, solve a trig equation. Find out solutions of sine 5x plus sine 3x equals 0. We're going to do the same thing. We're actually going to do a sum to product formula here to turn this into one term and make it a little bit easier. Okay, so this simplifies to 2 sine 4x cosine x. And from 0 to 2 pi, I'm just going to list them all because we have to from 0 to 2 pi. We have 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4, where this would be true. And our last question is to verify the trig identity, sine t plus sine 3t over cosine t plus cosine 3t equals tangent 2t. Okay. So I'm going to use the sum to product on top and the bottom. We have the cosine of negative t on the top and the bottom. Those can go away. So what I have left is 2 sine 2t over 2 cosine 2t, which is, the 2's cancel, just tangent of 2t. Okay, so again, I did the sum to product on both the top and the bottom of that fraction and simplified. 2 is canceled, cosine negative t is canceled, and I get tangent of negative of 2t when I simplify. Our homework for section 5 is right there. And that was section 5.5.